So for today, we are going to talk about multiple models in R, of course. Let's see, we will talk about multiple models. And let me save it in somewhere like Okie dokie. So sometimes when you have big data sets or a larger data sets, you may want to run a particular model for several times. And for today, we will see how we can do it in an automatic way for this lecture. And for multiple models, we aim to use that Gapminder data in a library Gapminder. Maybe you already know that library. And here are the libraries we use for this lecture or video. One of them is Plot.li, and so one of them is Gapminder. We will use that one for our data sets. And also we are going to use library model R, this one. And maybe as usual, we will use tidyverse. And it's a very common library we load for almost every R session. And we use something like bin R CPPP. And I don't know why we are writing this one. Let's see. So we use that simple models and multiple models for complex data sets. And Gapminder is the data about life expectancy around the world. And it's promoted by Hans Rosling. He's a Swedish doctor and statistician. And maybe if you do not know him, you may want to watch this video of him in here. Let me just open this part in here. Stop share, and I'm going to share this one with you guys. Yeah, this is Hans Rosling. Maybe you already know about him. So for today, as I show you the Gapminder web page, we are going to use that web page in here. Okay, let me remind you one more time. For for this one, let's see. Here is the Gapminder web page. They are adding lots of information and data sets in here. When you just check out for the resources one more time, you may want to see some materials, and also in here we have the data sets. And for each data, there are these indicators in here like life expectancy, income, child mortality, and also they have main titles for some of them. And you may want to see their other categories in here that you can check out. Okay, this is the Gapminder.org, www.gapminder.org webpage. And also in R, and there's a library, they already added some part of this data sets in Gapminder that we are going to use for today. And here is the library. Here is our Gapminder in here. Okay, and we are going to use that library for today and in R, and to try to analyze the data sets for countries and maybe for continents for today, okay? And see how the world is changing. And in here, we will see some, the data sets as, let's see, when I write Gapminder, let me write Gapminder in here. Yeah, here is my data set. And when I just write that one, it's a table type. And you will see that the main data frame Gapminder has 1,704 times, or this is the rows, times 6 variables for this data set. Of course, when you go to gapminder.org, you will see lots of data sets. But as a specific of this library in R, they just add the country, the continent, year, life expectancy, population, and GDP per capita, okay? And this is a simple type, and we will see more detailed about this data set for today. And the country is just a factor with 152 levels in here. And when you just check out for the continent, and it's also another factor with 5 levels, okay? And the year ranged from 1952 to 2007, and in increments of 5 years, okay? Every 5 years, we are able to see how these life expectancy or populations are changing in these data sets, okay? And life expectancy is the life expectancy at birth. It is in years also, okay? And the POP is the population, and GDP per capita is in US dollars, and it's just the inflation adjusted for these data sets, okay? So if we just do STR, and this is a main comment we are using to see the structure of the data sets, we can just write STR gapminder, and you will see that this is a table, and it's like a table format data set, and we are able to see all the variables and their types in here, like country and continent are factors, and we have integers and numeric values in here. And as usual, I can use head of these gapminder data sets, and I'm able to see the first 6 lines, and you see that first country is Afghanistan in here, in maybe Asia in here, and then we are able to see year life expectancy and population and GDP per capita. And another comment I use when I just open the data set is summary, okay? Summary comment, and I like to use that one too, because it's giving me some more information about the data sets in here. For example, for each country, I have 12 values. And for continent, for example, in Europe, we have 360 countries. And the minimum years is 1952 and maximum is 2007. And maybe it is interesting to see the life expectancy. The mean is 59, okay? And we have the population and GDP per capita. And since they are numeric values, we are able to see the main statistical statistics in this for these variables in here, okay? And also, there's one more thing we can do. We are able to see the checkout for the table. And let's see, I want to see the gapminder data sets, and for which of them. Let's see, for continent, I want to see the frequency table, and you see how many countries we have as in here, okay, as in this column. And we can use head STR summary table as a first step to get a general idea about the data sets. These are the main tools that you can use to get a general idea about your data sets in here. So first thing I want to do for this data set, after seeing some statistics, I want to see some visualization about these data sets. So we are going to use this gapminder, and I want to type it, and we are going to use ggplot. And so you should add the aesthetics in here for ggplot. First one is year, and I have life expectancy, this one, and I want to group it by country, okay? And the group is going to be the country in here. And so I'm going to have one line for each country for this plot. And you also should add what type of plot are you looking for. And since it is going to show how life expectancy is changing by year, it's a good idea to add a line plot in here, okay? And maybe we can add one more parameter in here as alpha 1/3, and it's going to change the line type in here, okay? When I run this part,
Professor, it just looks like hair. Like, where is the change?
Maybe for overall look, you may see that life expectancy by year is just increasing, okay? It is like a similar sense that we may see the video of Hans Rosling. He was showing that how the life expectancy is increasing for each country by year, okay, by time also. But when we are checking for this line plot, please remember that each of these line is showing one country. And maybe in some countries, we see some unexpected behavior in here, okay? And also, if you want to see it in a more fancy way, you may want to add a color for these countries in here. Let's see, I have the same plot, year by life expectancy. And in June line in here, I want to add more parameters like an aesthetics also. For color, I want to add the color as country. For each country, please add one color for me. And so again, the line type this time is going to be 1. You can just play with these parameters for you guys. And you can also add that theme for more flexibility for your data sets in here, okay? And I don't want to add any legends position for this plot in here, okay? Just play with the parameters for ggplot. And this is almost the same with the previous one, but we only added the colors. I think this is much better for me to see in here. And also you can just add one more color for continents. You can group by continents for these plots. It is depending on what you want to do for your plots in here. Just play with that one, okay? Just look for the first main one and look for how you can change by changing these parameters in ggplot in here. Okay, there's millions of ways that you can change your plots. So in overall, by looking at these graphs, they depict improving in life expectancy steadily in here. But of course, there are some countries with different patterns in here, okay? Let's generate a subset including one of the countries in here. Instead of using the whole data sets, I just want to get one part from this data, okay? I want to just filter for Turkey. And you can just play with that one and try different countries, of course, always. And here is the filter command. I will use Gapminder. And here is the country. And I have, if it is equal to Turkey, please choose that one. Now you will see that we have a new data in our global environment as Turkey, and it has 12 observations of 6 variables. And now we are able to see our new graph. Instead of whole data sets, now I'm going to use Turkey, and I type it. And let's continue with ggplot. And we have the aesthetics again. And please just put what you want here. And I want to see year by life expectancy. And again, since it's showing the change in time, it's a good idea to add a line plot in here. And so I also want to add a title this time by using GG title. And you can just say whatever you want. I want to add as Turkey. And here is what. And for Turkey, you see that there's a great increase in life expectancy by years in this plot, okay? And it's kind of a linear trend. And if it is a linear trend, maybe it's a good idea to see if I can run a linear model for Turkey. And let's see what I mean. I want to just run a linear model by using lm function in R. And so the response variable can be life expectancy in here. And by year, year is our exponential variable for this example. And my data is Turkey. This is what I filter already. And let's give it a name. And this is my Turkey model. And I run this part. And if you want to see the results, please remember that you should write summary for your linear model in here. Turkey model. There you go. Here is what I have. First of all, I can see the call, that means the formulation for my model. And you will see the residuals, which are almost around 0, and the median is small. And I'm able to see the coefficients. And you will see that when you are looking for the p-values, especially for year, and this is the statistically significant because p-value is smaller than your significant codes in here or the alpha value in here. And when you just check out for R-square or adjust R-square, it's really great. And it's a really high amount of R-squared. And we can say that we are able to explain the change in year versus life expectancy has a linear trend, and that increase is statistically significant, okay? And this is the estimation. We can see that for each year and how one amount of increase in year is going to change our estimation for life expectancy in this example, okay? And also, we are able to add a linear trend for Turkey by looking at this model in here. Let's see what I mean. Again, I want to use my data set Turkey. I will pipe it, and I'm going to add that predictions for my plot. Here is my predictions. I want to get them from my Turkey model, and I will pipe it again. And then we will plot these predictions by using ggplot. And we have the same parameters in here, aesthetics, year by prediction this time, instead of life expectancy. And you will see how your prediction is changing by using this line plot. And now you are able to just add the GG title as like, this is a linear trend in this example. Okie dokie. And when I run this plot, it's kind of similar to the real one, but of course this is a linear line thread. And when you just check out for year by prediction, you will see that this is your model for this example. Here is your linear model line on the plot for Turkey. And so what if it is required, or you should run the same model for each country? Maybe you remember that when we just check out for the summary for these data sets, we have seen that there are 1,632 countries. And if you want to run the same model for each country, then you have to run more than 1,000 models or just plot this one. This is kind of a soup. You will just generate a model soup if you want to run the same model for each country, okay? And so you may try to run the model for each country separately. Then today you will not have time to study for your exam or to check out for your Instagram page for today, okay? This is taking lots of time. Or you may try map function in pure library in here, okay? There is this map function in pure library. Here is the library, here is my map function. And we are going to use that guy to see all the linear lines for each country in here. But first, we kind of need to manipulate the data sets to prepare for this library in here. We will generate a group data by country and continent. Then we will generate a nested data frame in here. But first of all, before doing that, let's check out how our data set looks like, okay? Here is my data set. I have my Gapminder. Please remember the data set. And I just want to see the original data sets by country and continent, okay? Here is my data set. I have one line for each year, you will see that. And I'm able to see the country and continent in here, okay? And this is how the data set looks like in Origin. Please try to remember this part. Here is my data sets, okay? Please try to remember. And now what we will do that, we will just generate a group data sets by country and continent and just nest the data in here, okay? And I should first give it a name, this because it's going to be a new data set for us. And this is nested country. What we are going to do is that we will use Gapminder data and pipe it, and we will just group by country and continent. There is what. And I want to do is as nested. Okie dokie. When I just run this part, and if you want to see the nested country, and now this time it generates a data frame with a column that is a list of other data frames. It's kind of complicated in here. You see what? I have one line instead of like a general data frame. Now we have one list. This is 12 by 4. It just nested or shrinked the data sets. And now I have one line for each country, and their data sets is just nested in one data frame in here as a list, okay? After having our nested data sets, now let's see the first one, for example. I want to use my nested country data sets. And the data, you will see that I have one column named as data. I want to see the first one. Okay, here is my data. And if you want to see the first one, since it's a list, you should use double brackets in here. And let's see, I have the first one was for Afghanistan in here. And we are able to see the change in year for these 4 variables, okay? Now, what happened is that this table, 12 by 4, is this guy. Okay, you just nested your data frame in a table as a list in here. Please get the idea. This part is kind of important. So please observe that each row is an observation in a group data, and each row is a group in a nested data in here. So if you want to run a linear model for each country, now we should generate a general linear model function in here. Let's see what I mean. We will generate a linear model function. So now we are going to generate a general linear model function, okay? And then we will run this function for each model. And first of all, let's give it a name. I want to just call it as country model in here. Okay. And here is your function. Function df is the one argument that we will use. And I want to use linear model. You can just play with this part. And for life expectancy versus year, and this is going to be run for our data as df. So what it says that you are just giving a df, I mean the data sets, and that function is just running a linear model in here and looking for life expectancy versus year in here. So we are going to apply, first run this part, of course, and R has now one function in the global environment in here. And now we will apply this model to every data frame. And since these data frames are in a list, we will use map function in pure library in here, okay? And let's see what I mean. Here are my models. I'm just giving a name. And I will use map in here because, please let me repeat, the data frames are in a list in here. And what I will use that, I'm going to use nested country that we already generate these nested country data sets. And we will use this data in here. Please remember this part. In our nested country data set, we will use data, I mean these tables, for this model. And it's going to just run this country model for each of these data sets. Here is my country model. And map is just running this country model for each data. When I run this part, I have my models. Now I'm going to add this output next to the nested country data with mutate function in dplyr library. Let's see what I mean. I have my nested country data sets. I just want to change this data set and just add a new output. And again, I have my nested country. And I want to just add the results of the previous models. I'm going to mutate in here, okay? And I want to add a model data or model column in here. And how it is going to do that, I can just run this map part with data and my country model, okay? And here is my country model. Please remember the nested country first. Here is our data sets. Now we are adding one more column in here and the name is going to be model. And when I run nested country now, you see that I have my data again in here as a table. Now we added one more column in here, which is a list and the output of the linear model. And now we will use that output for our models in here, okay? So we have all the outputs embed into our data sets. Let's check, for example, for Europe, okay? I want to check out the output for Europe. I have my nested country, I type it, and I'm going to filter, let's say for continent, as if it is Europe. Here is what. Now I'm able to see all of them for Europe. And please make sure that the data is ordered by country and continent in here. How we can run this part is that we have our nested country again. Now we want to arrange them. Since I want to have the ordered data by country and continent, let's first write the continent and then country. This guy, okay? And now we arrange them. You see that I arranged them by country and continent in here. And we want to find residuals for each country. Let's see, I want to add the residuals in here. And how can I do that? Again, I can use the mutate function in here. So let me go over this part. So we already have our nested country, okay? What we have done is that we just generated a generic function, okay? We will just run this function as a generic one. So what will happen is that when you just check out for your nested country, here is my nested country, and so we have our data in here, and for each of them, each of this table, I want R to go to this country model and just add that data in here and run this linear model for me, okay? Since they are in list format, I'm just using map. And what is happening in here is that it is just getting my country model function and adding this part as an argument in here. This one is my argument, okay? This is what is happening in here in this part. So we've just run this one as models as an example. But what I want to do is that I want to add the output next to my data sets. I can run this want by using mutate in here. So this is my nested country. I'm adding one more column in here as model, this part. And this one is just the thing that you are just running your country model for each country by giving data in here. Please remember, you have your data as each country. What does it mean in here? You are running your linear model for each country in this example. And we just see the Europe as an example in here, okay? And at the end, you just arranged by continent and country in an alphabetical order by writing arrange, okay? This is what just happened in this example. And also, I want to find the residuals for each country in this example. Let's see what I mean. I have my nested country again, and I want to add one more column to my nested country. Here is my nested country. And again, by using mutate function in here, I want to add a resids column. This is going to be a new column for us, guys. And now I want to use map2 instead of map, just a similar one. And it's just a variant of map that iterate over multiple arguments simultaneously in here, okay? They are parallel in the sense that each input is processed in parallel with others, not in the sense of multi-core computing, okay? Let's see, I'm going to use map2 in here. This is very similar to map. We are going to use data and model. And also we will add the residuals. We have them already in the model, okay? And when you just check out for your nested country, this time, this was your original data and you added your model. And now we added our residuals for each country and for each year in each country in here. And we are going to use these residuals as an output now. Let's unnest the data set and you will get the idea much better, I guess. For resids in here, I'm going to unnest my data set, nested country for resids in this example. And if you want to check out for resids, now you have your country, continent, data is in table format and model is table format. They are nest, they are not unnest now. And you unnest the resids parts. You have your already life expectancy, I mean year life expectancy, popular GDP per capita. And resids is the one that you get by using this part, okay? Now we are able to see all residuals for our data sets. And now we are able to use these data sets. I can just use these resid data sets to generate a graph of residuals in here. Let's see what I mean. I have my resids in here and I'm just generating a ggplots for this example. I have my aesthetics in here by year and resids for this example. And now I want to again add geom line for this example. Let's add aesthetics. Let's group by country. And also you can add an alpha as a parameter for your lines as 1/3. And again, you may want to also add a smooth line. I want to add a geom smooth to use GAN model for this example, okay? This is up to you guys. You can just play with them. And I don't want to show the standard error on the plot, okay? Here is what. So now we just run these residuals for each year in here, and we added a general additive model. And this is the model line for you guys, okay? And now we have these residuals and they are generally around 0. And linear models works fine for some countries. You may see that since they are around 0, it really works fine for some countries, actually most of them. But maybe you recognize that we have some outliers in our data sets. And this is a sign that for some of them, this linear model may not work. And also you can just plot that residuals for each continent and see which one is behaving differently in this example. Okay. And now we will plot same residual plots for each continent. Okay, let's write it. We will plot for each continent for this example. And again, we are going to use that resids data sets that we already generated. I want to add a ggplot again by using the same aesthetics, which are year and resid. And then we have group by country. Okie dokie. Now you can add more parameters in here. Yes. So we have ggplot again. We want to add a new new parameters in here. One of them is the geom line that we want to have a line plot in here. And alpha is just a parameter for your lines. And we want to add a facet wrap for this example because I want to run this example for each continent. Please remember, by facet wrap is just separating your plots by the variable you are just giving in here, okay? And I just run this part. Now you will see that we run residual plot for each continent. And for example, for Europe, it's a kind of linear model works fine because they are all around 0. But maybe you recognize that especially for Africa, the residuals are really higher. And even we have some outliers, okay? Please indicate or please infer that Africa has a different trend comparing others, okay? And please think about it. Is it really possible to model Africa with a linear trend in here? Maybe just ask this question to yourself, and you may try some different models for Africa in this example. And also for the rest of the lecture or the video, I want to use the Broom library, okay? In Broom library, there is a function which is glance. It's a really nice function, and we can able to check out for some different indicators for a statistical models by using that glance function. Here is my glance function, and I can use my Turkey model to see some different indicators in here. For example, R-square, adjusted R-square, and the p-values and AIC and BIC values in here, okay? This is a very useful function. And I want to add the output of same function for each country at the same time. Let's see what I mean. Again, I have my nested country data set. I want to pipe it. Okie dokie. And just mutate to add a new column in here. And I want to add it as a glance. The name is going to be glance. And we will use again the map function to use model in here. And also in Broom library, I want to use my glance function in here. You can add this part or not, because I already know where is glance. And so I want to add this one, the glance part again, and I want to unnest at the end, okay? Unnest this glance part. Okie dokie. Now I have my data sets, and when I unnest my glance part, it just gives me the R-squared, adjusted R-square, and sigma values in here. These are going to be very useful for me, guys. And I want to drop rest of the columns for my example, okay? Let's see, I want to generate a new data sets. just with R squares, okay? And give it a name as, sorry, glance. Here is my new data set. I'm generating a new data set by using my nested country data. I pipe it and just mutate. Just do the same job you have done before, okay? I want to add a new column as glance. Here is my new column. How it is working that? I map it by using model, my model. And also we have our broom glance function that is just giving us some R square values. And when I'm unnesting my data sets, I'm going to unnest only that glance part. And when I'm not unnesting now, this time I want to drop the rest of the columns, okay? When I say drop as true, drop is false as default. And when I say drop as true, it's going to just drop rest of the columns, okay? And when I just glance in here, you will see that I have my glance data sets with R square, adjust R square. I think it's kind of similar to the previous one. Now, we want to see the models that don't fit well for these data sets, okay? I want to arrange R squared. Here is my glance. Oh my God. And I want to pipe it. And if you just arrange by your R squared, you will see your R squares from smaller to the highest one. You see that, for example, in Africa for Rwanda, the R square is really, really small. It is even minus, which may not be so true for the model. That means for these guys in here, the linear model is not working, okay? It looks like the worst models are generally for Africa in here. And I want to just see it in a better way. Let's see what I mean.
Maybe as the guy said, because of the pandemic that happened there in the 90s.
Maybe that one.
Yeah.
In the video of Hans Rosling. And the glance data set, I want to add another ggplot to see how well it works for my model. And now this time, for each continent, okay, I want to see my R squared values, okay, and see how they are changing. This time you can just add a geom jitter. It's another type of plot in here, and just play with this width parameter in here. When I run this guy, you will see R squared for each continent. And except Africa, for all the continents, you have really higher R square values for your linear model. And you can say that, okay, I can just use this linear model for Americas, Asia, Europe, and Oceania in here. And there's only 2 countries in here. And when you just check out for Africa, you will see that there are even some countries, their R squared values are smaller than 25% in these examples, okay? Maybe you may want to just plot data with that smaller R square values. There's another way in here, okay? I want to generate a new data set and give it a name as smaller fit in this example, and just filter your data sets. And please remember our last data set was glance. And I want to just filter these data sets with our squared values if they are smaller than 0.25. That means I'm just having this part and just filter my data sets. Here is what. I just filter glance with R squared. Now, I want to add another gapminder plot in here and just semi-join That means you are just joining your two data sets. And I'm using my smaller fit and I want to join them. That means you are just merging your data sets in here by country. Okay? It's going to merge your Gapminder and smaller fit data sets by using country in here. And after that, you want to add a ggplot. And your aesthetics are your year and life expectancy. And the color can be by country in here. And now we want to add a geom line that we add several times for today. Okay. Now, before running a ggplot, we are just merging our Gapminder and smaller fit data by country in this example. And I think this part did not work.
Bir de R-Squared'de nokta koymamışsınız sanırım hocam.
Şurada mı?
Solda, sol tarafında. R-Squared'in R nokta squared kısmı sanırım.
Thank you. Thank you very much. Okie dokie. Now we are able to run this part and we join two data sets. Now we are able to see for these 6 countries, the linear model is not working well because the life expectancy by year has a really different, maybe non-parametric trend for these 6 countries. And now we were able to just filter that part by using the functions we use like map, like glance in here. Okay, I think it's a very good example to see the whole world, especially for the continent by graphs, and to understand how the countries or how life expectancy is changing for each country in here. And now you are able to see the differences in a much better way by using the very good options in R for this example. And if you try to do that by hand for each country, believe me that it's going to get a lot of time from you guys. So as a last step, I want to show you an animation plot with Gapminder. I'm going to just add the animation plot codes in here, and then you can just able to run this plot li. Plot li is just generating an animation plot for you. And for this example, we will use Gapminder and GDP per capita and life expectancy, and the size is going to be population, color is going to be continent. And we will have a frame by year and text by country. And these are the another parameters you may have in here. This is a ready to use code in here. And now we have that plot we have by year and life expectancy. Please get the idea that each color just showing one continent in here. For example, if you see that pink, that means you are in Europe. And when you just go over the plot, you are able to see the name of the countries in here. And this plot is kind of similar to the one in Gapminder or Hans Rosling TED video in there. And when you just run or play, you will see how it is changing by year from 1952 to 2007.
That's so cool. Oh my God.
The size changes according to what?
Can you just repeat the question? Size?
The size, yeah, the size of
the size was the population. Maybe you may see in here.
Okay.
And the size is changing by population. And when you just play your plot in here, it's really easy to get the plot, I guess. And you will see how life expectancy is getting higher and the GDP per capita is also increasing by year from 1952 to 2007. And you can also use this plot for another data sets. This is a very good example in here. And I want to add at the end of this lecture, I want to add that I use this book that Hadley's and Garrett books are for data set to prepare some part of this video.